Again. Hello guys, welcome. We're doing the volumes quiz. Happy spring break. I hope you guys are kicking butt, and let's get started. So y equals x, that says sketch the region bounded by the curves y equals x cubed, y equals 1, and x equals 0. Then find the volume of the solid generated by revolving this region about the x-axis. So y equals x cubed. So let's see. Y equals x cubed looks something like this. And I am exaggerating it so we can see the region easier. Y equals 1 looks something like this. And x equals 0 looks something like this in green. So the region they're talking about is this one right here. That's your region, because you're bounded by all three of those. And then I'm revolving about the x-axis. So I'm going to revolve it about the x-axis. Well, I guess you guys would get mad with that arrow, right? You guys want to... Okay. So when I revolve it around the x-axis, it's going to look like this. This region here. And it's going to look... let me put some points first. And then something like that, guys. Should be having more of a curvature. Oh well, there we go. That looks a little better. And bam. Okay, so here's my cross section. That cross section is a washer. Anytime there's a gap, it's going to be a washer. So here we go. Volume equals pi integral from 0 all the way to, that value is a 1. Travis, how do you know it's a 1? Well, y equals 1, so 1 equals x cubed, so that means that x has to equal 1. So 0 to 1, and then the big R is the distance from up here to the x-axis, and that distance is always 1, so 1 squared minus, and then the distance, the little r, is the distance from this curve to this curve. That curve is just x cubed minus 0, so I'm just going to say x cubed squared. So big R squared minus little r squared, close it, dx. So I hope you know what we're doing, guys. This is your cross section right here. Area of the cross section is pi big R squared minus pi little r squared. On the quiz that we had before you guys left for spring break, a lot of you are kind of being robotic and you don't know where this comes from. Look, if we factor out a pi, guys, if we factor out a pi, you have big R squared minus little r squared. And that's all we're doing. And then some of you guys didn't even put the integral symbol. You just put a, and then you just put volume equals whatever. You have to have that integral symbol, guys, because we're adding an infinite amount of cross sections, guys. So it's obvious that we need more practice with this. So when we come back, we'll hit you guys with this. But anyways, so here we go. Pi integral 0 to 1 of 1 minus x to the 6 dx. And you can go ahead and use a calculator, but this is easy enough to not have to use a calculator. X minus x to the 7th over 7th. And then this is evaluated from 0 to 1. You still have a pi on the outside. The 0 is going to zero out everything, but the 1 is not. So I'm going to write pi and then 1 minus 1/7. So 1 minus 1/7 is 6/7. So with the pi on the other side is 6 pi over 7. All right. Try to do as much as you can without a calculator, and then when you need a calculator, 3, 2, 1. All right, guys, let's look at this question here. It says, sketch the region bounded by the curves y equals 4 squared of x, x plus y equals 5, and y equals 2. Then find the volume of the solid generated by revolving this region about the x-axis. So your first job is to sketch this region. You might want to put it in the calculator, but I think you can do it without one. So 4 squared of x looks something like that. This is y equals 5 minus x, or negative x plus 5, whichever one you think is easier. Here's 5, here's 5. It looks something like that. And then y equals 2 looks something like, boom. So the region they're talking about is this region right there. That's a region. So let's rotate this about the x-axis. So when you rotate it about the x-axis, it's going to look something like, let's see, the distance from here to here, that's 1, or that's 2, sorry. So I'm going to put a point there, put a point like here, and then that distance is probably something like there. So it's going to look something like this. Now I want you to notice that this region, let me focus specifically on this. If you want to erase the other lines, you can. So here it is you're going to have two integrals, guys. There's no way around it. So check it out. This integral here, this cross section, it's a washer. And then this cross section here, it's another washer, but it's dictated by different curves. Different curves are going to determine your big R and little r. So here we go. We need the intersections, these three intersections. So the first intersection, you can either find it with your calculator or you can do it by hand. I think it's easy enough to do it by hand, guys. Let's see, the 4 square root of x equals 2. Divide by 4, square root of x equals a half. Square, x equals 1/4. So that's one of the intersections. And then the other intersection is a linear line and the square root. So 4 square root of x equals 5 minus x. I think I'm going to square everything. Square. So I'm going to have 16 square root of x equals 25 minus 10x plus x squared. All I did was square it, guys, so parabola. Oh, I don't have the square root x. I just have x, right? Almost found a mistake there. Subtract that 16x. So I'm going to write the x squared first. 0 equals x squared minus 16 and 10. That's 26x plus 25. That is factorable. Let's see. X minus 25. X minus 1. So it's obvious that it's either 25, it can't be that, or 1. So that has to be x equals 1. And let's get the last one right here. So let's see, that's a linear line, both linear lines. So it's 5 minus x equals 2. Switch that. X equals 5 minus 2, that's 3. So there we go. I got all three, and we're ready. We're ready to rock and roll. So my volume is, now remember, you have three different equations. You're going to have two integrals from pi, and it's a washer, so pi and then big R squared minus little r squared. Pi, the lower limit is 1/4. The upper limit is a 1. And the big R is the distance from the x-axis to that curve there. So that is 4 square root of x squared minus, and the distance from the x-axis to this constant there, or horizontal line, and that's going to be a 2. So 2 squared and close parenthesis dx plus pi integral. Let's see, on this second one here, this is my second one. And big R is the distance to that linear line. So from 1 all the way to 3. And that's going to be 5 minus x. So 5 minus x, close it squared, minus, and again, that's 2 squared. Close that, and then put a dx. And there it is, guys. So when you do that, let me type this into my calculator. You can do it by hand, but I'm just going to do it by calculator because it's just faster, guys. 4 square root of x squared minus 2 squared plus, and I'm just going to put the pi afterwards. Math 9, 1 to 3 of 5 minus x, close it, squared, minus 4. Enter. I get 15.166667. If I turn that into fraction, I get 91 over 6. So my volume is 91 pi over 6. All right, guys, here we go. Let's do this question next. Sketch the region bounded by the curves y equals square root of negative x squared plus 25 and y equals 0. Then find the volume of the solid generated by revolving this region about the x-axis. All right, you guys have all had Algebra 2 and Pre-Cal. You should recognize this immediately as a semicircle centered at the origin. If it would have had a plus minus in the front, then it would have been a circle centered at the origin. And how do we know that? Because when we had Pre-Cal and Algebra 2, x squared plus y squared equals r squared. There it is, centered at the origin. And if you square this and then move the x squared to the left, you have x squared plus y squared equals 25. So immediately we know that r equals 5. So if you take the top half of the semicircle and you rotate it about the x-axis, what shape are you going to have? What shape, guys? No, I can't hear you guys. It's going to be a sphere. If you take a semicircle above the x-axis in 2D and you rotate it about the x-axis, it's going to be a sphere, guys. So I hope you guys can see that. So if you just take your volume formula, 4/3 pi r cubed, you can solve this immediately without calculus, recognizing that. But if you don't recognize that, well, then you're going to have to do it the calculus route. So here it is, the calculus route, and we'll do both, guys. Negative 5, 5, and 5. And then I'm going to rotate it. So there's my circle. What's your sphere actually now? So here it is in three-dimensional. That's an area of a cross-section. That cross-section is a circle. Pi r squared. The radius is the distance from here to the top of that curve. That top of that curve is this guy. Negative x squared plus 25 square root of that. All of that squared, so it's going to go away. So my volume is equal to pi on the outside, negative 5 to 5 of square root of negative x squared plus 25. Close it, dx. Make sure to put the square on it. So there it is. When you type it into the calculator, the square root and the square cancel each other out, and you will get 500 pi over 3. Now, this can be done without a calculator, guys, but I went ahead and did it in my calculator. Now, if you were to recognize, you can just plug in that r equals right there into 5. So let's see if it would have worked. 4/3 pi times 5 cubed. 5 cubed is 125. 125 times 4 is 500. And OMG, 500 pi over 3. Look at that. You would have gotten it right. And no calculus. So you can see how it works, guys. All right, let me get a little bit of my juice here. Yeah, it tastes good. All right. Sketch the region bounded by the curve y equals secant x. Remember, that's a reciprocal of cosine. X equals negative pi over 6. X equals 0, and y equals 0. Then find the volume. All right. So in case you don't know how secant x looks like, you can type it into your calculator, 1 over cosine x. And you're going to see a whole bunch of vertical asymptotes. Every time that x is pi over 2, pi, 3 pi over 2. Sorry, not at pi. Pi over 2 and 3 pi over 2. Any multiples of pi over 2 or 3 pi over 2. And let me type in, all right, so it's going to look something like, if you zoom in, so let me zoom in on my little table. See this window, it says negative pi over 6, so I'm going to put negative pi over 6 as my min. And it says y equals 0, that's the x-axis, and this is x equals 0, that's the y-axis. So I'm going to make my x max 0. And that's it. That's all I'm going to do. And then y min negative 1, y max 1. If you plug in pi over 6 into cosine, that's square root of 3 over 2. And square root of 3 over 2 squared is 3 over 4. So 3/4. But negative, right? Because it's negative power. No, it's positive. Y min, Y max, Y1, 1 over cosine. Should have graphed. Why didn't I graph? I'm in radian mode. Negative power 6. Oh, my window has to be bigger because it's reciprocal. So if you zoom in, it really looks like this, guys. It looks like that. Negative pi over 2 and pi over 2. But I'm zooming in extreme, and you're zooming in extreme right here. So when you do that, it's going to look like this then. You zooming in extreme, and there it is. That's the region that we have. And we're going to rotate this about the x-axis. So it's going to look like a disk. So a of x is equal to pi times the radius, which is secant x squared. So my volume is pi integral from negative pi over 6 to 0 of secant squared. So let's see if we can do this without a calculator, guys. Leave the pi on the outside. Antiderivative of secant squared is just tan, because the derivative of tan is secant squared. So tan x from negative pi over 6 to 0. And maybe you do, maybe you switch the polarities here, or switch negative pi over 6 to the top and 0 to the bottom and put a negative in the front. I didn't do that, but maybe you do. Tan of 0 is 0 minus tan of negative pi over 6 is going to be negative because pi over 6 is in quadrant 4 in the unit circle. So remember that at pi over 6, at negative pi over 6, your x value is square root of 3 over 2, and your y value is a negative half. So you're going to have minus, let's see, negative half divided by that, that's going to be a negative 1 over square root of 3. So negative times a negative is a positive. Put the pi back in. So pi over square root of 3. They're going to rationalize it. So multiply by square root of 3 over square root of 3. So pi square root of 3 over 3. So to the next one, guys. Sketch the region bounded by the curves x equals y cubed, x equals 1, and y equals 0. Then find the subvolume of the solid generated by the y-axis. This is actually the same question as number 1, verbatim, but that's fine. They just changed the equations. This is like saying y equals x cubed, y equals 1, and x equals 0. And if we recall, y equals x cubed, y equals 1, x equals 0. OMG. So it's pretty much the exact question. But I'll show you how that looks like, guys. It looks like this. So there's x equals y cubed. Here's x equals 1. And here's y equals 0. This line right here in green. So they're talking about this region. And I'm rotating this about the y-axis. Or I guess the other way around. But whatever. And it's going to look something like. And again, you have washers. And these washers, they look like that. So it's going to be the integral, let's see, pi, well, let's just go right into it, guys. My volume is going to be the pi integral y equals 0 to y equals, let's see, y equals 1, because that's the way top, that's where they intersect, that's the y value there. And then the big R is going to be 1, so 1 squared minus, and then that's a y cubed, so it's going to be y cubed squared, that's your little r, dy. Now notice this integral is almost the same as this integral. It's actually the same, the exact same, it's a dummy variable. You're going to get 6 pi over 7. And there it is, guys. Sorry, took a little break and took a sip on my coffee there. Sketch the region bounded by the curves y equals 8x squared and y equals the cube root of x. Then find the volume of the solid generated by revolving this region about the y-axis. All right, both of these curves are going to touch at x equals 1 and x equals 0. At 0, you can see that they're both 0. And at 1, they're both 8. Let's see, which one's going to be bigger and which one's going to be smaller? Well, this is x to the 1/3, and this is x squared. So in case you're not familiar with this or you don't have enough practice with this, if you go to your y equals and just type in x squared, and then on y1 and then on y2 you can just type in the cube root of x, or x to the 1/3, and you can see what graph is on top and what graph is on bottom. I would go from 0 to 1 for x and 0 to 1 for y, so you can see more or less a lot clearer. So let me do that real quick. 0 to 1, 0 to 1 graph. And I see x squared, and then I see the cube root of x. So I see that the cube root of x is on top of the x squared. So it's going to look something like this, guys. Here's your x squared, and then here's your cube root of x. Let me do it in blue. And then I'm rotating this about the y-axis. So it's going to look something like a petal. Well, not really a petal, guys. It looks a petal in 2D, but when it's actually like a bowl kind of with a curvature on the inside because it's being rotated. And my cross section is that? Oh, what happened there? Something crazy happened. All right, my cross section is that. Oh, it actually looks pretty cool, guys. So here we go. First, we already know that this is 1 and 1, but this is a dy. Notice that cross section is a dy, so we need the y value. The y value way up here is 8. So here we go. Volume equals pi integral 0 to 8, because the bottom value here is 0, the top value there is 8. The big R is the distance from the y-axis to that curve, guys. So we need to have it in terms of y. That's your x squared. So y equals 8x squared divided by 8 divided by 8. X squared equals y over 8, square root. X equals the square root of y over 8. So that's what we need. So I'm going to write square root of y over 8, and this is going to be squared, that's big R, minus the little r. So here's the little r. I'm going to do that in blue because that's what that equation was. So I'm going to write, what am I going to write? Oh, yeah. Y equals 8 cube root of x divided by 8. So cube root of x equals y over 8. And then cube and cube, x equals y over 8 cubed. Y over 8 cubed. Oh, that's a mistake. I guess we can put 2 parentheses. Y over 8 cubed there, and then close it squared. And then close the whole shebang, dy. And there it is, guys. When you type it in the calculator, you'll get that. You don't need to type it in the calculator if you can do it by hand, but it'll make the job a lot easier there. All right, here we go, guys. Sketch the arena bounded by the curves x plus y equals 2. So let's go ahead and see if we can sketch that. So x plus y equals 2. So here's my y-intercept of 2. Oh, well, that was great. And so that means y-intercept of 2. That means, y-intercept of 2 and then slope of negative 1. So down 1, right 1, down 1, right 1. So yeah, it's going to be at 2 as well. So there we go. We got that guy. And then this guy here. So y equals negative 4x plus 8. That also has a x-intercept of 2, but the y-intercept is 8. So it looks something like that. And it looks kind of like the star, what is it? Not Star Wars, but the other one. Can't remember the name of the other one. Star Wars, and it looks like that. And notice right here, up here, that's just a disc. But down here, that's a washer because there's a gap. So you got to find out that value, and you're going to have to do it with respect to y, as you can see. So that value there is 2. We already know that. So 0 to 2. So let's go ahead and see. So that's a washer. So I'm going to go volume equals pi integral 0 to 2. And the outside curve there is this guy there. So we'll just make it easy. So giant parenthesis, smaller one, and then we're trying to solve for x. So it's going to be 8 minus y divided by 4. Close squared minus, and then it's this one here, solve for x. So it's going to be 2 minus y, close it squared, close the whole thing, dy, plus, so there's my washer, plus, from 2 to 8, and the radius is just this guy here. 8 minus y, divided by 4, close it, put a square on it, dy. And let's do that with my calculator real quick. With the top one here, you get math 9, 0 to 2, open parenthesis, 8 minus x, close. It's the same thing, guys. Divided by 4, close the whole thing. Let me insert another parenthesis. Second insert parenthesis. 8 minus x divided by 4, close the whole thing, squared, minus, open parenthesis, 2 minus x, close, squared, close. Back to x, enter, and I get, on the first one, I get 7 pi over 2 plus, now on this one here, math 9, 2 to 8, and then 8 minus x, close, divided by 4, close, squared, and on this one I get 9 pi over 2. So 9 pi plus 7 pi, that's 16 pi over 2. And 2 goes into 16 8 times. So there it is, guys. Alright, so here we go. The base of a solid is a circle x squared plus y squared equals 64. So again, that's centered at the origin with a radius of 8. So not bad. Negative 8, 8, negative 8, 8. Find the volume of solid given that the cross sections perpendicular to the x-axis are isosceles right triangles with a leg on the xy plane. Okay, so that's not bad. So here it is. That cross section is the leg. It's coming out of the board. So that cross section is this part of the triangle. It's this. So remember that this top curve here in blue, that top curve is y equals square root of 64 minus x squared, and then the bottom curve here in green, or I guess let's choose a different color, in black, that bottom curve is y equals the negative square root of 64 minus x squared. All right, so now we're good. So this total distance here is that cross section here, and that distance is going to be twice. So I'm going to write 2 square root of 64 minus x squared. You can always do upper minus lower, and you can see that they would add up. So that means this guy as well, 2 square root of 64 minus x squared. And that's all you need, because you know it's an isosceles right triangle. So area, my cross section is 1/2 base times height, 2 square root of 64 minus x squared, 2 square root of 64 minus x squared. So this half cancels with that. So here's my area. So my area cross section is just going to be 2, and then the square roots cancel out. 64 minus x squared. I'm not even going to bother to distribute. You can if you want. Volume is equal to integral from negative 8 to 8 of 264 minus x squared dx. And I guess technically I need to have a parenthesis there. So I type this into my calculator, math 9. I mean, you don't have to, you can do it by hand. So here we go, 2 parentheses, 64 minus x squared, close dx. And I get 4,096 over 3. The base of a solid is a triangular region bounded by the y-axis and the lines 2x plus 5y equals 10. Alright, so let's see how that looks like. 10 minus 2x, close, divided by 5, and 10 minus 2x divided by negative 5. Find the volume of the solid, okay. Negative 10, 10, negative 10, 10. It says, find the volume of the solid given that the cross sections perpendicular to the x-axis are squares. Okay, so I have something that looks kind of like this, and I'm bounded by the y-axis and these two lines. So that means that it looks like a triangular region. You have something like that, and that's coming from the one with the negative slope, which is this one. So this curve there is y equals, and I just did this, 10 minus 2x divided by 5. And the other line looks like this. Not like that, guys. It's supposed to be a linear line. There we go. Let's pretend that they meet there. And that this curve is y equals, that's this one here, 10 minus 2x divided by negative 5. Negative divided by negative is a positive. So there's my region. And when I cut it like so, it's coming out and they're squares. So it should be pretty easy. So here is my cross section. And this distance here is just upper minus lower. As you can see, it's the same, almost the same line. So this minus a negative this, that's going to turn into a positive. And you're going to have two of those. So 2 of the 10 minus 2x, 10 minus 2x over 5. And since this is a square, all sides are the same. So my volume is integral from 0. And I do got to figure out where they touch the x-axis. So let's see, what makes the y value 0? It looks like it's 5. 2 times 5 is 10. 10 minus 10 is 0. So from 0 to 5. And I can put the 2 on the outside, or I can leave it on the inside. No, don't put the 2 on the outside, unless you put 4. 2 parentheses 10 minus 2x over 5 close squared, because it's a square. So there we go, guys. So let's go ahead and take care of that. Math 9, 0 to 5. Oops, I put 8 by accident. Open parenthesis, 2, open another parenthesis, 10 minus 2x, close, divided by 5, close. And we'll put a square on it, and then dx. And I get 26.666, turn that into a fraction, and 80 over 3. Alright. Sketch the regions bounded by the curves 10x squared and 10x to the 1/3. Then use the shell method to find. Okay. If you get the shell method, we're going to exempt it. Yeah. Well, yeah, let's exempt it for now, guys. Only if you get the shell method. Oh, here's another one that says shell method. Sketch the region bounded by the curve, then use the shell method. If you get the shell method, for now, guys, we're going to exempt it. This is not tested on AP. We've done it in the past, but right now with spring break, we're fine. Let's see, if this one shell method again. Shell method, yep. So exempt. If you get lucky and you get all 3 shell method, you'll be exempt. Alright guys, that's it.